Section 2.2 is an introduction to matrices. To introduce a matrix, I'm just going to draw just a random matrix like this. It's a rectangular array of elements. A rectangular means it can be different length than it is width, and we'll talk about how we label that here. So I can have 1, 2, 3, 4, 5, 6. And each of these are separate elements we call of the matrix. So this is one element, two elements. It has 6 elements in there. Okay? So each one of those separate guys are all elements of that matrix. What we call these now, dimensions, we say are row by column. So this matrix right here has 1 row, 2 rows. So it's a 2 by 3 column. It has 1 column, 2 columns, and 3 columns. So it's a 2 by 3 matrix. All right. And we talked about a row is a horizontal ones. A column is going vertical. If you remember it, like a column of a building, that'll help you remember it. Square matrix. A square matrix has the same number of rows and columns on it. So like we could have a 2 by 2 or a 4 by 4. So a 2 by 2 would be a matrix like that. So just one example. So definition number 1 about matrices says 2 matrices are equal if and only if they have the same dimensions and are identical element by element. So identical means that they equal each other. So in this case, element by element means y plus 4 is one element. It has to be equal to the same element that corresponds with it. So y plus 4 has to equal x. And in this case, y has to equal 2x. And if they asked us to solve this, we would go ahead and solve a system of equations. I'd use substitution. 2x plus 4 equals x. So I would subtract my x over, subtract my 4 over. I get x equals -4 and y equals -8. So if they were asking us to solve that matrices there, matrix equation. Definition number 2, the sum of 2 m by n matrices is an m by n matrix in which, so it has, notice it has the same dimensions, in which the elements are the sum of the corresponding elements of the given matrices. So this is actually way easier than what that definition makes it sound like. So all we're doing in order to add matrix A and B, so it says add A plus B, so that means add matrix A plus matrix B, is all I have to do is look at corresponding. So the very top left has to be added with the very top left here. So matrix A plus B would equal, on my top left, 2 plus a -5, which is -3. And then if I move then to my corresponding, -4 plus 7 is 3. And then again, go ahead with corresponding parts here. -1 plus -4 is a -5. -2 plus a -8 is a -10. 3 plus 1 is 4. -8 plus 4 is -4. So again, now we have a new matrix, and that is A and B added together. All right. Now they're going to ask us to find A minus B. Well, that's easy enough. I gave you a hint to cross the line. So cross the line and change a sign to a negative. And when we change a sign to a negative, what we can do is we can just change every single sign in here and add. So now my A minus B is going to be 2 plus a +5, which is 7. 4 plus a -7 is -11. -1 plus 4 is 3. -2 plus 8 is 10. 3 plus a -1 is 2. And -8 plus a -4 is -12. So that's how we subtract matrices. Not too hard. It says now to find 4a. Well, this is just multiplying by what we call a scalar multiple. A scalar is just some number is all we're multiplying it by. So I'm going to multiply this thing by 4, and all that means, so the matrix 4a is just going to be 4 multiplied by every single unit in that matrices in A. So this is going to be 4 times 2 is 8. 4 times negative 4 is negative 16. Negative 4, negative 8, 12, and negative 32. So that's easy enough, right? Operations with matrices really aren't that bad. Okay. Something that we got to identify here, a zero matrix. Matrices have an identity element, just like every other operation. An identity element, in case you didn't remember, means that whatever I do, whatever operation I do, say it's addition. In this case, the zero matrix is going to be the identity for addition. Whatever I do, that thing's going to stay the same. So like the identity for addition, for regular addition, 5 plus 0 equals 5. I added the identity to it, which makes whatever I added to it stay the same. So that's the identity. The identity for multiplication is 1, because 7 times 1 is that same thing we took it by, is 7. So the zero matrix is just full of zeros. Whatever matrix I add to a matrix full of zeros is going to be the matrix itself, the first one itself. So that's what the zero matrix is. And that's the identity for addition. There'll be a different one for multiplication and so forth. Definition number 3, the product of an M by N matrix and an N by R matrix is an M by R. Now, so one thing to notice here, I realize that this is getting a little confusing with all those letters, different letters in there, but I have one matrix that's M by N, and I have to multiply that by a matrix that's N by R. What we need to notice is that when we multiply matrices, the only matrices that we can multiply is if this first matrix, if that's columns, are the same number as these rows. And I'll show you why here in a little bit, because how we multiply row by column. So we have to have the same number of rows as we do columns in order to multiply. All right? And the resulting one we're going to get is an M by R. This is going to be the resulting matrix that we'll get. All right? In this case, we don't really see that play out too much. We have a 2 by 2. We can definitely multiply those. We have a 2 by 2 matrix. So in this case, it would be a 2 by 2 times a 2 by 2. Well, we can multiply it because these are the same, and we're going to end up with a 2 by 2 matrix. Okay? So how we multiply these is we're going to multiply row by column. All right. So row by column. For my first element of A, B, I'm multiplying them together. I'm going to multiply row by column, and I'm going to add. So I'm going to say 3 times 2 plus negative 2 times 4. That's my top left element. All right, so that's that one. Row by column again says we're going to stick with that first row. I shouldn't erase that. I'm going to stick with this first row and go to the next column. That's going to be my top right element. So I'm going to say 3 times a negative 1 plus negative 2 times 6. Okay. All right. And then we got to do our remaining 2. I'm going to go row by column again, 2 by 4. So a negative 1 times 2 plus 5 times 4. And then row by column again, I'm going to go negative 1 times negative 1 plus 5 times 6. Row by column. All right. So now when we work all this out, I'm going to have 6 plus a negative 8. So AB is going to be negative 2 in the top left. So then I'll have negative 3 plus a negative 12, which would be negative 15. And then down here at the bottom, I'll have a negative 1 plus 20, which is 19. Or sorry, negative 2, so it would be 18. Sorry, negative 2 plus 20. And then down here in the bottom right, I'm going to have a positive 1 plus 30, so I'm going to have 31. So we multiply row by columns, and that would be how we do AB here. Okay, so you got to multiply all the rows by all the columns, and you'll get your resulting matrix. So I hope this helps. We'll see you in class.